All right, here's some help with quiz 1.06. This quiz deals with different types of transformations. So the first two questions, they're going to give you some shapes and ask you to pick out the ones that have been reflected, translated, or rotated. So just an overview. A reflection, remember another term for a reflection is a flip. And it has been simply reflected over this line of symmetry. Now the line of symmetry can be various places, but notice when we flip this over, imagine that this is on two sides of a piece of paper, and this is the middle of the paper, and we flip them, they're going to match up. Okay, so notice that this is A, B, and C. When it's reflipped or reflected, notice my C is over here and my B is over here. So let's take a look at a couple examples. If I were to draw a line of reflection here and I were to fold this piece of paper, notice that this would line up here. So we can tell that's a reflection versus just a translation where we slide something down. If we slid this down, then this would be on the bottom here. Same thing with here. If we slid this over, then this part would be over here. And so this is a flip or a reflection. And we could draw in our line of reflection right here. Of course, that's not very straight, but if we drew our line of reflection and flipped that over, they would match up. Another example we can see here. And the way you can kind of look and tell that this is a reflection is that if I just slid it up here, then my C would be on this side. But this is a reflection because I can draw this line of reflection, and this figure has been flipped. So if I flip it, my B would match up here, my A would match up here, and my C here. And another thing about the line of reflection is each point is the same distance from the line of reflection. So if I were to measure the distance from C to this line of reflection and here, that distance is the same. For translations, the way you can recognize a translation is it is simply a slide. Another term from this is a slide. And we're simply going to move the figure right or left and up or down. So notice this has been moved down here. We've got our pre-image. Our pre-image is what we started with, and now we're moving it or sliding it down here. So our A's match up, our B's and our C's. Notice that they are in the same orientation as our first one. So here's some examples. You can see this arrow is simply slid down. The arrow is still in the same direction, so that is a translation. Here we've got these two figures. Notice that this part is still upright, so we have simply slid that. We've gone down and over. Another example, notice these two triangles. If we were to draw a line of reflection here, then this would be flipped over and our C would be over here. So this, they've just taken it and slid it down. So the C is in the same place, the A is in the same place, and the B. So that's how you tell if it is a translation. And then last that we're going to talk about are rotations. Rotation is we're simply going to turn. So the other word for a rotation is a turn. Think about a wheel. And when we turn this figure, notice it could have a different orientation here. We can turn things counter. This is our pre-image, so if we've turned it, we're turning it counterclockwise. So unless they tell you otherwise, just assume it's counterclockwise. So for this figure, if we turn it around, we've turned it about this point. So we can see that we didn't just slide it, right? If we just slid it, it would still be, it wouldn't be touching it like this. This one has been turned about this point right here. So that tells you that it's a rotation. Same, another example, if you look at these two triangles, notice that they're the same size, but we could draw a line of reflection. It hasn't reflected over, right? This would go over here. And it hasn't been slid down because my F would still be down here. So we can tell that this has been rotated. Number 3 on the quiz is going to ask you some things about rotation. And as far as if you rotate an object, you can rotate a certain number of degrees called the angle of rotation, and then you rotate it about a central point that's called the center of rotation. So in this little figure here, the center of rotation is right here. Think of that as if you had a wheel, that would be the center of the wheel. You're turning it around that point right there. Now we can turn a figure on a point that is either on the figure, inside the figure, or outside the figure. If we turn it on a point, if the image is going to touch the pre-image at more than one point, then the center is inside the figure. So let's talk about that. If, let's say this triangle, that I'm going to turn it about this point right here. Think of that as my center, and I'm going to turn this around. I'm going to touch this figure many times, right? So I'm going to touch the pre-image many times if I'm turning about a point inside the figure. If I'm going to turn it about a point on the figure, let's say I pick point B, and I'm going to rotate this around point B, then I'm not going to touch the pre-image except in this point right here. Now, if I rotate it about this point, let's say that this is my center, and I'm going to pick this up and rotate it around that center, I'm not going to touch my pre-image figure at all, right? So that's what 3 is talking about. And then number 4 is on translation vectors. So when you translate a figure, you slide it in a straight path without rotating or reflecting it. The straight path that the figure takes has a direction and a distance. So the distance and the direction is known as a translation vector. So if we took this figure and we slid it down here, we've got this little vector here. And this is called our translation vector. It shows the distance and the direction that we move the figure. So an example of the question you're going to have is, which of these translation vectors, R, Q, or S, is used for this pair of figures? So this heart has been translated. It has been slid up here. So we could look at these and say which path. So I've got these so I can kind of move them a little bit. So if we were to use that vector, that's kind of short, right? It didn't move. It didn't show us the correct distance. So it's not R. S, well, that's not going in the right direction, right? Even if we put it there or if we put it on this figure, you can see it doesn't match up the direction. So that's not the correct answer. This one, notice if we put it there, voila, it shows the direction and the distance that this figure was moved from here to here. Number 5 is just mainly asking about some definitions about transformations. Now, transformations, these are 3 of the transformations we talked about today, and they are called rigid motion or isometric transformations. The reason they call that is they preserve, whether we flip it, turn it, or slide it, it's going to preserve. We're going to have the same size, the same area, the same angles, and the same length. So the figure is still congruent. It's not going to change. So that's going to be true with rotations, reflections, and translations. Hope this helps you with the quiz.